All right, welcome. Let's get started. We're not going to take roll today because I'll just have you upload a program script file that you're going to create today, and I'll base your attendance and participation points on that. All right, so as a beginning announcement, your homework assignment related to the material we're covering today and Tuesday's class, that assignment is due on Tuesday. It should be uploaded to MU Online before 11 a.m., which is when our class begins. Now today we're going to take our MATLAB use to the next level. Everything that we did in class on Tuesday was kind of like you entered it directly and it was doing the calculations one time only. But today what we're going to learn how to do is how to save commands so that they can be executed over and over again. And so those are called scripts. It allows you to do a lot more complicated things. So here's a list of some of the new tools you're going to add to your MATLAB toolbox today. Okay, so as I already mentioned, last time you had some exposure to the fundamentals of MATLAB, but none of your work was saved. So that if you wanted to do those things over again, you'd have to type all of the variable definitions and all of the numbers back into the command window another time. So none of your work was saved. In order to save it so that you don't have to reprogram anytime you want it to start defining variables and performing calculations, those scripts can be saved. And scripts are saved with a file extension of .m. But really all they are is text files. And you can open up a .m file with the notepad or any other kind of text editor and just look at what you see. The only difference is that when you open it within MATLAB, you'll have line numbers that makes it a little bit easier to keep track of and reference different parts of a program as compared to if you open an M file within a notepad editor, or even when you print an M file, the line numbers don't show up. So when you begin a new script, you'll click on the ribbon of the program, this new script tool, and then it will it'll open up a new window that you haven't seen previously before, and that's where it starts to number each of your commands that you're giving it. And it's also, we'll talk a little bit later about how to identify the location that that script should be saved, because MATLAB gets awfully concerned about what directory it should be looking at for input files and where it should be writing output to. And so as you'll see as we work through an activity together, it becomes important to, in addition to starting a new script and saving it, to tell MATLAB the folder that the script should be placed in and should be looking for input and output data from. So here's what it looks like when you push that new script button. It opens up an editor, and you can see that the line numbering is one of the distinctive features as compared to the command window that we were working in before. So it'll make the command window a lot shorter than it was before. It'll still be there, and the command window is where you'll see any prompts that your script asks for. It's where you'll see the result, like the output of the script, if you want the results of the calculation displayed on screen. We're going to create a script in class today that demonstrates each one of those tools that were mentioned earlier on the title slide for today's lecture. All of the rules still apply as before. All of the rules about what variable names have to be, for example, that they're case sensitive and that there are several words that can't be used as variable definitions because they're reserved for other purposes. You'll still use semicolons to suppress an output in the command window because, remember, it echoes things when it receives an input, and you can suppress that echo with the semicolons. So all of those same things still apply. Now the other thing to keep in mind is that those line numbers are there to give you an idea of the order that MATLAB is going to be reading in and considering operations. So just as an illustration of how it's important to consider what comes first and what comes next, this input on the left side wouldn't be correct because you're performing a calculation with x before you've defined what the variable x is on a numeric basis. But on the right side, you can see the correct version of that same idea is that first you're defining a numerical value for x, and then in the second line, you're performing a calculation that calls on that variable. Okay, one of the important things that you need to do in scripts is leave notes to yourself and anyone else who is going to be looking at your program. And you can do that with the % symbol. That is called a comment. And engineers sometimes are surprised when they graduate and start working how important the communications aspect is of the job. You know, I found in my own professional career when I was working for a consulting firm, I did about 10 hours of writing for every 1 hour of calculations that I performed. And so writing is a really big part of the job, whether you're writing to your boss explaining what you did, or writing notes to yourself so that you can remember how to do something again in the future, or writing to clients. And so putting comments into a script is really important because you're explaining how the program works, and it can be useful to people who are trying to debug it or to take sections of the work that you've done before and modify it for something else. So when you use the % symbol to create a comment, it will turn the text in the window green. And just to emphasize, that commentary is a service not only to others but also to yourself, because inevitably you'll be coming back to programs months or even years later that you've written, and you won't be exactly sure what the idea was behind a certain line. So if you have comments, it means that you don't have to reinvent the wheel another time. So here's an illustration of how comments can be used in the same line that a variable is being defined. So for instance, g equals 9.81, that's the gravitational acceleration constant in SI units in terms of meters per second squared. But you could say that to yourself in the program by doing %, which means everything after that the computer isn't going to perform any calculations with on that line. It's only there for the benefit of the people who are looking at the script later on. And it's in green to give you the additional indication that it's a comment. And you can see that this comment has both the definition of G and also the units there. In addition to having a line-by-line explanation, it's also customary at the beginning of a program to put in just a very brief explanation of what the program is supposed to accomplish overall. So kind of like an overview of what it's doing, in addition to the detailed notes later on. So here's a look at a MATLAB script that's used for some structural engineering calculations. You can see that here in the first 3 lines, they're indicating part 1 of the program. Now, MATLAB itself isn't going to be looking at that and thinking, okay, this is part 1. MATLAB is just pursuing in a line-by-line order, and it doesn't necessarily need to know the structural components of the program in the same way that a person would benefit from having them delineated. So there are different sections. There are comments to let you know what's happening. These are the specimen dimensions, the stiffener locations, and so on. And then with each line, comments are provided as well. A lot of information there, and you don't want to have to figure out how a program works more than once, and the comments allow you to do that. So poor programming doesn't have comments. Clear program does. Now, if you use the keyboard shortcut of Control-R on a line, then that would add in automatically the %, and it would change it into a comment. And Control-T will take a line, and if it previously had the % at the beginning to indicate that that's a comment, it will take it out again. Now, in yellow here, it's explaining that sometimes if your program isn't working, you may want to take out part of the program to see if it'll begin to work when you disable a section of the program. And rather than actually taking the section that you want to temporarily remove and taking it out, instead of doing that, it's just easier and maybe safer to put temporarily on just a short-term basis these percent signs in front of the lines of code that you want to disable, because it'll take something from an operational part of the program to an unoperational part of the program. So it's a quick way to debug and find out where in your program a mistake might be, turning it temporarily into comments. Another nice thing that MATLAB will do is it's always looking at your script and sort of on the fly, even before you run it, it's trying to understand what you're doing and flag errors where they might be. And so if you have a section of the scroll bar that has these the red indicators, then that means that there's a syntax error that needs to be corrected before the program is going to run successfully. Yellow and orange indicators over here on the side mean that there may be some way that you could improve the script, like make it shorter or more efficient. And green, which is what you want to see, means that there's no errors that have to be improved on. All right, so what we're going to do as our activity today is we're going to do some financial calculations. I think maybe a handful of you maybe have already taken Engineering 221, and this is a formula that you have seen in engineering economy. What this formula does is it tells you the value of an investment that you're making today based on compound interest. Like if you put a lump sum into the bank and it accumulates interest over a certain number of compounding periods. So in our example, what we're going to say is, as a starting point, what if we had $100 as our principal, and the bank is paying 5% interest per year, and we're going to leave that money in for 20 years. We want to know what is the future value of that investment. Now, just one note is that when we're defining variables into the program, we can't use I as one of the variables. And so here in the instructions, you should use int as the variable for the interest rate rather than the letter I that you'll see in the formula. Now when you do the calculations for $100 at 5% interest for 20 years, when that compounds into some future amount, it's going to be $265. So that's how you know if you've done it right. Let me give you a couple of other ideas before you actually start working on this. When you're ready to run the script, here's the Run button that you're going to click on. The green Go indicator is sort of a visual reminder that it's going to run what's been saved. You should save the script that you're going to create today either on your V drive or on a flash drive, because you want to have access to it as you're working on the homework. You know, it'll be a valuable reminder of different syntax and the formatting that these commands have to be in to work. And also you're going to need to upload that M file to MU Online today for participation credit. So when you go to save and run it, you'll probably get a pop-up message that's asking about the folder that MATLAB should be working in. Even though you save an M file, that doesn't automatically tell MATLAB that it should be reading and writing other things from that folder. And so if you just click on the Change Folder button, then that'll automatically take it from whatever default folder MATLAB was working in to begin with to the folder that you saved your M file into. So in our cases, that'll probably be somewhere on your V drive. It'll automatically change. You can, in addition to clicking on the Run button, you can also run the program by typing the name of the M file, like future is the name of it, in the prompt. And so it will see that you're trying to access that M file, and then it will execute it. So you'll still have the variables being defined in the workspace, and then the output for the calculations will be here in the command window, which is where, in last class's period, that's where we would be defining the variables. But instead of defining the variables in the command window, we're going to do it as a script. All right, so I'm going to leave this screen up for you to work with. What you'll need to do is start MATLAB, and right now we don't see the script window, so you'll click on New Script, and assuming your computer is faster than mine, there it is, it popped up the editor. Okay, so in the editor, you need to follow these instructions for what should be in each line. All right, so what it's done is it has calculated the future value based on $100, 5% interest, and n equals 20. And so on the thing here, it said the answer should be 265.33, and that's what it gave us, 265.33. Do you have a question? Chances are that's not true. Let me see if I can. Okay, your file name has to comply with the limitations that MATLAB has on defining variables. So I think that means you can't start your file name with a number, potentially. There can't be spaces in the file name. When I did that earlier today, it gave me a warning message. I'm surprised that some of you, it just failed without giving you that warning message first. But if you've got it typed similar to this and you're still not getting it to execute correctly, then change the name of it by doing save as, and then save the name to something simpler or a file name that complies with MATLAB's requirements for variables. All right, so now that you've got it saved, what you could do is you could close MATLAB and open MATLAB again. And just to clarify what it saves, it only saves the script that was typed in. It doesn't save the result of the calculation unless you execute the script another time. So here I'm starting MATLAB. I'll open that script. Maybe I shouldn't have closed it. Maybe I should have just closed the script rather than the entire program, because it really opens slowly. All right, so if I run it again, it'll execute this, but before it ran it, these variables weren't defined in the workspace. So we could change it to $110 and run that, and now it's got a different future value. Or we could change it to $200 and run it, and a new future value. So, I mean, it's nice to not have to type all these in again, but we can even improve on what we've done so far. Okay, here are some new tools to add to your programming lexicon. One thing you can do is use the display command to show text or parts of a variable, and then the input command will ask the user for a certain number or input to be assigned to a variable, so that the variable isn't assigned in the program structure but can be assigned on a case-by-case basis. So here's how the format should be used for the display. This display feature just puts something on the screen, and it's kind of like a comment, except for the comments we've done so far with the %, that goes into the script file. This display is a comment that will come up on the screen when the script is executed. So in this case, you can see that it's an explanation to whoever's running the script that the program is computing the future value of an investment. Now the syntax for that is that you have to have the parentheses both at the beginning and at the end, and then you have apostrophes just to show that it's text. It doesn't have to be these exact words. It can be anything inside of the apostrophes. And if we add that, then this is the output that would come from your program. It would give the display message, and then it would give the future value. So that's what you could put into line 2 of our program. Remember how line 2 was empty? So here in line 2, we could put in DISP for display message, and then the apostrophe. This script will compute the future value of an investment. Close apostrophe and close parentheses. So that if I run that again, it gives me the message that helps whoever's running the script to understand what this F is supposed to be. It's a future value of an investment. It's always good to save your work. Okay? So that's the display command. So the way that the input works is it makes it so that the values, for example, $100 and 5% and all of that, it makes it so that those values don't have to be defined in the script, that they could be defined on the screen in real time by the user. And so before, what we had was the present value was 100. Let's change that in the program so that instead of being 100 all the time, it will ask the user on screen to put in an amount. And so here's the syntax for that. We're going to say that the variable p isn't 100. We're going to say that p is the result of the input. And there's two parts inside of that input. There's the text that they'll see, and then the other part is whatever they enter is going to be assigned to that variable. Okay, so go to your program structure here, and where we've got p equals, you probably have 100. I had 200 because I was playing around with values. Change that to be input, and then some text. Maybe a couple of extra spaces just so that they don't have to enter right on top of the text. All right. So if we run that, now that we've made the change, it says enter your principal. So we have the message. It says enter your principal, and it's waiting. It's not telling me the amount of the value of it. So I have to type in. Now right now you can see over here in the variables, p is 200. If I enter 100 and then enter, it changed p to 100, and then it executed the rest of the script. So that now f is 265.33. So I could run it again and change my future value, change my principal to maybe 150. And it calculates the new f. I can run it, change p to be 7,000. And it'll calculate the future value based on 5% interest and based on 20 compounding periods. So that's useful, right? Yes, of course it's useful. All right, so if you rerun it, that's what we saw. It allows you to change the principal to any amount that you'd like. So let's do the same thing, but change it so that it's going to ask for the interest rate to use and the number of periods, so that you can define the interest rate and the number of periods. All right? So I'm going to pause the recording and give you a moment to do that. Got to be careful not to screw up my script. All right, so did everybody get theirs to work? So you get to change all three of those variables on the fly. All right. Now, why was it that earlier on I said not to put the semicolon? Let's see, where were those first instructions? Here, where I said don't use a semicolon after line 7. Exactly right. Exactly. So what he means is if I put that in, so if I do put in that semicolon there, watch what happens. It'll still run and it'll still put the answer over here in the variable definitions, but it won't show up in the command window. Okay, so I'm going to save what I did. I put in that. I'm going to run it now. So here I'll put in my principal, 100, interest rate maybe 11%, number of years, 25 years. Okay, it ran it, it knows the answer, but it didn't put it on the screen. So that's why the semicolon was missing from line 7 before. Okay. Now, you can call on a variable by using the display. Now, display will put some text on the screen, and then you can also have it display more than just some text that's inside the parentheses. You can have it display the result of a variable. So before, what we've been doing in here is it's just been shooting out f equals and then the answer. But what we want to do is we want it to say the results of your calculation, you know, some sort of text that explains and gives context to the output there. Okay, so add this line, this to line 8, and then create a line 9 that says display f. Okay, so in other words, we're going to have the semicolon is there, so that's suppressing f from being displayed. But we're going to create the display command. Your resulting future value is, and then display f. So I'll save that and run it. Okay, so it asks me for the principal, $10,000 at 2% interest rate for 10 years. Your resulting future value is $12,189.94. So that's kind of nice. Yeah.
So why do you put the semicolons on page 9?
For the at the end of the display?
Yeah.
I guess they probably don't need to be there. Let's see. Okay, 12,000 at 1% interest for 50 years. Yeah, they don't need to be there. They're extraneous. Because the display, the semicolon means to like suppress the echo, but the whole point of the display is for it to show up on the screen. Okay. Here's what we can do to make it even more powerful. We need to include programming logic. And programming logic allows the program to make decisions based on the size of input compared to some criteria. So we call that a relational operator. It's the greater than, less than, equal to, not equal to. So here are the operator commands that will allow MATLAB to make decisions. And combining that with an if-then statement. So in this window, this is showing just a brief explanation of how MATLAB could be used to assess somebody's grade and whether or not they passed. Like if you didn't know whether 42% was a passing grade, then you could create this program, and when it executed, it would say, if the grade is greater than or equal to 60, then display you passed. And if that's not true, if it's not greater than that, then it would display you failed. So this is an idea of the syntax of how if-then statements can be incorporated into a program. There are a couple of different options for how if-then statements work. This first one is the simplest, and it will only do something if the if statement is true. What we saw before was if it's true, it'll do one thing, and if it's not true, it'll do the other. So it's an either or. The last kind is kind of like a nested if-then statement. It can have as many parts as you want. It can be broken up into lots of different sections. So it'll look at the conditions created in the first if, and then if that's not true, it'll move on to the next, and it'll check to see if that's true. And if it's not, it'll move on to the next. And at the end of all of those, if none of the ones before it were true, then it'll execute what else, the else part of the command. And where that would come in useful is if you wanted to assign a letter grade to a numeric value. So what this is illustrating is, let's say that somebody's grade is 82. What this script would do is it would first say, if the grade is greater than or equal to 90, then display you received an A. In this case, that's not going to be true, so it'll move on to the next part of it. So since it'll be triggered, since their grade is above 80, then it's going to display you received a B. But it'll keep going through each one of these until something's triggered. And if nothing is triggered, the last one is the display of you received an F, because the value of grade would have been less than 60 in that case, if nothing else had been triggered prior. Does that make sense? All right. So we can combine the relational operators and if-then statements with additional logic of and or. So these two things will allow you to combine ideas together where maybe two statements both have to be true for it to execute the display, or one or the other. So for example, if you didn't want to have that nested else-if statement, you could create a situation where a B is going to be something that's greater than or equal to 80, but less than 90. And so if, and inside of the if is the and. So the way that the and statement works is that there are two statements within the parentheses, and both of those have to be true in order for it to then do the thing below it. This would be a pretty pointless program. It only exists to tell people if they got a B. Yeah, but it gives you the idea of the syntax of how and is used. Now, sometimes the indentations will get a little bit mixed up. If you press Control-I, then it'll clean it up and standardize the indentations. You don't have to put in these indentations yourself. All right, so let's change our program a little bit, where afterwards it's going to analyze whether or not the amount of the future value satisfies whatever their investment goal was. So it's still going to do the same calculations that it's done before, but after it does them, it's going to say, so what was your goal? What were you trying to achieve? And then it'll look at the amount, and it'll tell them whether or not their goal was achieved. So we're going to do two things. First of all, have them input their investment goal, and then afterwards, on line 12, create an if-then statement that tells them whether or not their goal has been met. So you'll be doing the if, and then underneath the if, a display of either your goal has been met or else of the if is that it wasn't. So remember, just to look at the if and else syntax again, here's how it is. If, under that, some display message, then the else and some display message. Okay, so make these revisions to your program. All right, programming insults into the computer is one of the joys of working with MATLAB, so try and inject some ounce of levity or creativity into your programming. You know, actually, even if you go through the comments of certain programs, it's kind of notorious for like insults, you know, like Microsoft will be insulting Apple, and you know, like nerd humor, that sort of thing. You can do nerd humor. Be sure and save your M file, because you're going to need to upload that to MU Online. So did everybody get that to work okay? So it will judge you. It'll judge you for how much money you've got. High and mighty computer. Yeah.
Type in, like, it moves it over to display.
Uh-huh. And so is it not working okay?
It says error, legal use of reserved keyword
Let's see. Now, I'm not sure if it's seeing this if correctly. Make it lowercase instead of capital.
What about else too?
Mm-hmm, yeah. Go here to home. oops, what did we do? Okay, editor, sorry. Yeah, I wonder what's going on here. Did you save it yet?
Yeah, I just say,
Okay.
like you said, pausing, but
Okay, go down into here. I think maybe it's still running right now. Enter your principles. So I think maybe it was running, which is why it wouldn't. Okay, so now go back to the editor, click that again. Now, it's in the middle of it. I think that there's a, oh,
what was wrong? It's undefined.
error in line 3. I don't know. I'm not sure. Did you, you've got the display, right? Is it, do this continue here. Click continue. All right, it finished it, right? Yeah. All right, so we've got those display messages. Now, we already did the format bank to make sure that it was just doing cents and it wasn't showing lots of extra digits. You can also use the CLC to clear the command window at the beginning of your script. You don't want to do it after, at the end of the script, because then it'll display it on the screen so quickly that you won't be able to see the results. But we could just add this line up here, CLC there, and then it would clear out all of this nonsense before it ran it again. So it's kind of like a fresh start. So that's another thing that you could do. Now, the fprintf is a way of formatting and printing the results of the data. And so it's kind of like if we wanted to do a summary at the end of our program. So here's what you could do is in the past we're having 2 lines of display. Your resulting future value is, and then displaying the f. You could combine those 2 things together. Rather than making that change, let's add as a line 18 and 19. So in line 18 have fprintf and do like a summary. So to summarize, p equals, and then have %f p, so that it knows what variable to call on and how to format it. Okay, so I was in the middle of running my script before. I'm going to execute this newly revised one. Let's see what it does here. Enter my principles. So 100, interest rate 5%, 20 years. Oh, 20 years. My investment goal, 150. My goal was met, and it summarized the values for me. It summarized the input and the output. Yeah, let me show that again. So here's the whole script. fprintf, and what I've done, I wish there was a way to make that larger for you. Hopefully you can see that. The syntax is the f tells it that you're calling on a value. All right? So with those tools that we've practiced today, I think you should be able to do the homework assignment. I see it here. Let me just refresh my memory here. Doing some calculations. There's a series of hints inside of the homework assignment. And you're going to have to upload the M file for your homework assignment online in the same way that you are today for the in-class exercise. And so go to our course page, and if you scroll down to the beginning of the main page, you'll see this 3/30. Once you make the changes to your M file to include that fprintf, save your M file again, and then browse to whatever location that you've got to browse my computer and upload where you've got that M file saved. In my case, I did it into a temporary directory, MATLAB class 2, and it is the MATLAB file, that one. All right. So I can stick around for a couple of minutes to answer questions if you had any problems. But just to summarize, the assignment is due at 11 o'clock on Tuesday or before. And the way that you can access this program outside of class is to download Octave onto your computer. You can try and find a time when people aren't using this classroom, or what I've been doing is I've been using the MU remote to get onto the remote server from any computer on campus or off. All right, that's all for today. I'll see you next week.